Hi, this is Gerald Gonzalez, and I'm going to continue where Jessica left off. These are the three forms of quadratic equations that we have been looking at: the vertex form, the root form, and the standard form. And we're going to see if the students can apply these equations to a real-life situation. Here we have a picture that I downloaded from a TNS file from Texas Instrument. And you can see that the path of the ball, you can ask questions. Your engage part of the lesson is, what does this path of the ball look like? And hopefully by this point they have seen several quadratics, and you can ask specific questions about how does this parabola open? What is the vertex? Are there any roots? Some questions that we might be able to answer from this picture if we had a grid. And that's the cool thing about this is you can click on 2.1 and it's already put it on a grid for you, which is very, very nice. Now this grid has some tick marks and they give you some distances and some measures, and that's very nice. But what might be even more beneficial is if we had a grid on this graph. So we're going to hit menu, we're going to go to view, grid, and then put a line grid. So now we have what looks like what the students see as an XY coordinate grid. And it also gives us nice locations of where the ball starts, or approximate where it starts, and then the high point known as the vertex, and then some other aspects that we could also ask further questions. Now with this program or the calculator, I'm going to see if they can actually create a graph that we can put over top these basketballs and see if it is quadratic in nature. So I'm going to hit tab, and it allows us to plug in a function. Now one of the things that they might want to start off with is just doing x squared and hit it enter for comparison's sakes. Well, they know that it's not facing the right direction, and so they could go to tab and go back up to f of 1. Well, maybe some of them, you want them to make the connection that it is negative. And then retry it again. Well, it is now facing downward, but it needs to be a lot higher up and shifted over. So hopefully then they can start, oh, hey, let's start using the vertex form. So hopefully they can come out here and remember the form. That's the goal, is for them to use things that they've just finished seeing. So if you look at the vertex, which is right here, from the origin it would have gone to the right 1, 2, 3, 4, 5, 6, 7, then up 1, 2, 3, 4, 5, 6, 7, 8. So we'll say x minus 7. I'll put the parentheses there. And then I'll say plus 8 and hit enter. Now it did put our vertex in the right spot, but it did not make this quadratic compress. So they need to, there's a lot of playing around with this so they can hopefully see the connections. Now they'll probably come out here and maybe type in a 3 and hit enter. Well, that made the graph a lot skinnier and it stretched it. So let's go the other direction. Let's try something smaller than 1. Let's try 1/3. And then they can hit enter. Now it's getting wider and we're getting closer. So with a few more adjustments, I think they'll be able to get this. So I'm going to come back to this location, come down, and then I'll say 10. Okay, now we can see that. Let me move this out of the way. I'll grab it and I'll drop it so that I can see the path of the ball. Now we can see that most of the points or the basketball is directly on this line, and some of them aren't quite as good. So, we can talk about real life situations and errors and that type of things, but it gives us a start. Okay. Now what I am going to do next, the three forms that we had was number 1, quadratic formula in vertex form, and the next one is going to be in root form. Well, with this picture, we can now follow it down and we can see where the roots actually cross here at -2 and all the way over here at, it appears to be 16. Now, the compression still should be -1/10, so -1 divided by 10. That shouldn't change. And then we'll say x plus 2 because of the formula, the way we have to write it with the formula. And do our sets of parentheses and say x minus 16. Now, if we did this correctly, a new line will be drawn and it'll be directly on top of the red one. And it appears that we are correct. So I'll take this and I'll drag it. Now remember, during the first section of the Desmos demonstration, we had vertex form, root form, and we also need to have standard form. Now this one's a little more tricky, and I would suggest that the students actually, instead of trying to just guess and check, actually do a little, put the pencil to paper and kind of multiply these binomials and then multiply everything by -1/10. And then that way they can get to their answer a lot quicker. So I have -1/10 x squared plus 14/10 x plus 32 divided by 10. And then once I hit enter, well, there is the third equation, and it is in a different form, but as we can tell, it appears to be on the same line or the same quadratic path as the other ones.